Something unusual has just emerged from deep space, and it has left many music scientists stunned. For years, the James Webb Space Telescope has been quietly scanning the universe, returning images of distant galaxies, newborn stars, and cosmic structures that humanity had never witnessed before. But recently, one particular set of observations triggered a wave of confusion and intense debate among astronomers. The telescope captured something inside regions of space we thought we understood. Structures more intricate than anything previously recorded. Strange patterns surrounding distant stars. Massive galaxies that should not exist so early in the universe. And a set of images so unusual that some researchers openly admitted they didn't immediately understand what they were looking at. These discoveries come from some of the most famous and mysterious regions of the cosmos. The pillars of creation, the distant cluster known as Pandora, an unusual star system surrounded by strange concentric rings, and galaxies so massive they challenge the current understanding of how the early universe formed. Each of these images is extraordinary on its own, but together they tell a much deeper story about how much of the universe we still don't understand. And the first discovery begins in one of the most iconic regions ever photographed in space. One of the first targets observed by the James Webb Telescope was the famous structure known as the Pillars of Creation. These enormous columns of gas and dust lie inside the Eagle Nebula, roughly 1,000 light-years from Earth in the constellation Serpens. The pillars were first photographed in 1995 by the Hubble Space Telescope, revealing towering clouds where new stars are born. But when the James Webb Telescope pointed its infrared instruments toward the same region, the level of detail increased dramatically. Infrared observation allows Webb to peer through dense cosmic dust that blocks visible light, revealing structures hidden deep inside these stellar nurseries. In the new images, astronomers could see numerous young stars, embedded within the pillars, some of which appear to have formed only a few 100,000 years ago. The clouds themselves, appear far more textured and complex than in previous observations, showing how turbulent and active this region of star formation truly is. The new view, of the Pillars of Creation revealed something scientists had suspected but had never been able to confirm with such clarity. The interior of these enormous columns is filled with newly forming stars that were completely invisible in earlier photographs. These stars shine through the dust as faint points of infrared light, indicating that the process of star formation inside the nebula is still ongoing. Although the structures might look almost architectural in shape, they are not artificial formations. They are massive clouds sculpted by radiation from nearby young stars, slowly eroding the surrounding gas and dust. What the new images demonstrate is not the presence of alien structures, but the incredible complexity of cosmic processes occurring inside one of the most famous star-forming regions in our galaxy. After studying the Pillars of Creation, the James Webb Telescope turned its attention toward a much more distant and chaotic region of space known as the Pandora cluster. Formerly identified as Abell 2744, this enormous cosmic structure lies roughly 3.5 billion light-years away from Earth and is the result of multiple galaxy clusters colliding and merging over vast periods of time. Previous observations had already revealed part of this region, but earlier telescopes were only able to study the central core of the cluster. When Webb directed its powerful infrared instruments toward this location, the resulting image exposed far more than astronomers expected to see. Using its near-infrared camera and near-infrared spectrograph, the telescope captured several deep exposures that were later combined into a single panoramic view. The result was a remarkable image that balanced both depth and width, revealing structures that had remained hidden until now. Instead of just a few galaxies clustered together, The image, music, displayed an intricate cosmic field filled with thousands of luminous points spread across the scene, each representing a distant galaxy or star system far beyond the Milky Way. The panoramic observation of the Pandora cluster ultimately revealed nearly 50,000 distinct sources of red light, many of which correspond to extremely distant galaxies whose light has been traveling through space for billions of years before reaching the telescope. These faint red sources appear because the expansion of the universe stretches their light into infrared wavelengths, which the James Webb Telescope is specifically designed to detect. One particularly striking feature of the image is a bright foreground star from our own galaxy that produces sharp diffraction spikes caused by the telescope's optical system. Surrounding it are numerous glowing patches of white light. Music, representing distant galaxies embedded within the cluster itself. The observation also relies on a phenomenon predicted by Albert Einstein, where the immense gravity of the cluster bends light from even more distant galaxies behind it. This effect acts like a natural cosmic lens, allowing astronomers to see objects that would normally be far too faint to detect. The result is not just a photograph of a galaxy cluster, but a window into the deeper universe beyond it. Among the many images captured by the James Webb Telescope, one particular observation immediately caught the attention of both scientists and the public. The image showed a distant star system known as WR-140 surrounded by a series of perfectly spaced concentric rings expanding outward into space. At first glance, the structure looked almost like ripples spreading across the surface of water after, music, a stone has been dropped into a pond. The rings appeared to grow larger and fainter as they moved away from the central star, forming a pattern that seemed unusually regular for a natural astrophysical process. The photograph quickly began circulating online after it was shared by citizen scientists, triggering intense discussion among astronomers and space enthusiasts. What made the music image particularly puzzling was the shape of the rings themselves. Instead of forming perfectly smooth circles, some of the structures appeared slightly angular or squared in certain sections, giving the entire formation an almost geometric appearance. This unusual detail led some music observers to speculate about exotic explanations, while researchers worked to understand the physical processes that could produce such a pattern around a distant stellar system. As scientists examined the observation more closely, explanations began to emerge regarding the unusual shapes visible in the image. Part of the music's striking six-pointed blue structure surrounding the star was identified as an optical diffraction artifact created by the telescope itself, when observing a very bright stellar source. This diffraction pattern is produced by the telescope's optical design and can appear whenever intense light interacts with the edges of the instrument's mirrors and support structures. However, not everything in the image could be explained as an artifact. The reddish curved structures surrounding WR-140 were determined to be real physical shells of material expanding outward through music space. These shells likely formed as the star system expelled matter in repeated outbursts, creating layers of dust that gradually drift away from the star over time. Even with these explanations, the remarkable regularity of the structures continues, to intrigue astronomers. The observation shows how complex stellar environments can produce patterns that look almost artificial when seen from a single perspective, reminding scientists that nature itself is capable of generating structures that appear almost impossible at first glance. As astronomers continued analyzing the early observations from the James Webb Telescope, they noticed something unexpected appearing in several of the deep field images. Scattered among the distant background of the universe were faint red points of light that seemed far more massive than researchers anticipated. These objects were detected using Webb's infrared camera as part of early scientific observation programs, designed to study the formation of galaxies shortly after the Big Bang. The goal of these observations was to look back into the earliest stages of cosmic history and understand how the first galaxies formed from primordial gas. What scientists expected to see were small, irregular galaxies slowly assembling themselves over hundreds of millions of years. Instead, the telescope revealed objects that appeared surprisingly large and mature. Some of these galaxies seem to contain masses comparable to those of major galaxies in the present-day universe. This discovery was particularly surprising because the light reaching Webb from these objects originated from a time when the universe had only reached about 3% of its current age. According to existing cosmological models, galaxies of this size should not have had enough time to form so quickly after the Big Bang. The strange red objects detected in these observations became one of the most intriguing puzzles produced by the James Webb Telescope. Some estimates suggested that the brightest of these galaxies might contain masses approaching those of large modern galaxies, possibly up to tens of billions of solar masses. In several cases, their estimated masses appeared only a few times smaller than that of the Milky Way itself. For astronomers studying the early universe, this was an astonishing result. It implied that enormous galactic structures might have formed far earlier than current theories, music, predicted. Before rewriting the models of cosmic evolution, researchers began considering alternative explanations. One possibility is that stars in the early universe may have emitted light in unusual ways due to the lack of heavier chemical elements that, music, exist in later generations of stars. Another possibility is that the objects being observed are not exactly what they appear to be at first music glance. To resolve the mystery, scientists plan to analyze the light from these galaxies using spectroscopy, a technique, music, that breaks light into its individual wavelengths. By measuring these spectra, music, astronomers can determine the precise distance and physical properties of these objects. Music, allowing them to confirm whether the strange red points truly represent massive early galaxies or something entirely different. When scientists first began analyzing the new observations from the James Webb Space Telescope, they expected to uncover new details about the universe, but not questions this music profound. One image revealed hidden stars forming inside the pillars of creation, a stellar nursery where gravity and radiation sculpt enormous clouds of gas and dust into structures that appear almost architectural. Music, another observation, exposed the Pandora cluster in unprecedented detail, a vast cosmic collision zone where tens of thousands of galaxies glow across billions of light-years of space. Their light snorts, bent and magnified by the gravitational lensing predicted more than a century ago by Albert Einstein. Then came the strange patterns surrounding the star system WR-140, where concentric shells of dust expand outward in a formation so regular that at first glance it almost resembles a carefully designed structure. Some features in the image were explained as diffraction patterns produced by the telescope's optics. Yet, the physical shells surrounding the star remain a remarkable example of how stellar systems can sculpt matter into surprisingly ordered shapes. These discoveries alone would already make Webb one of the most important scientific instruments, music, ever built. But the telescope did not stop there. In the deepest observations of the early music universe, Webb detected faint red points of light that may represent galaxies, music, far more massive than scientists expected to find so soon after the birth of the cosmos. These galaxies appear at a time when the universe had reached only music, a small fraction of its present age, raising the possibility that massive galactic structures formed much earlier than current models predicted. Astronomers are now studying their light in greater detail, breaking it, music, into spectra that will reveal their distance, chemical composition, and true identity. Only then will scientists know whether these mysterious red objects truly represent giant galaxies forming at astonishing speed, or whether they are something entirely different. What makes these discoveries so fascinating is music, not just the images themselves, but what they reveal about the limits of our understanding. Each observation, music, opens a new window into the cosmos, showing us regions of space where familiar theories suddenly begin to strain under the weight of new evidence. The universe that once seemed predictable now appears far more complex. Music, filled with structures and phenomena that we are only beginning to understand. And perhaps that music is the most extraordinary part of all. The James Webb Telescope was built to look deeper into space than any observatory before it. But in doing so, it has also music forced humanity to look deeper into its own knowledge of the universe. Every new image reminds music us that the cosmos is far stranger, far larger, and far more mysterious than we once imagined. So the real question is no longer what the telescope, music, has already discovered. The real question is what it will reveal next. Because if these early observations are any indication, the universe may still be hiding music secrets that will completely change the way we understand our cosmic origins. And if you, music, want to stay updated on the most fascinating discoveries coming from the depths of space, make sure to subscribe, music, to the channel, activate notifications, and join us as we continue exploring the mysteries that the universe is only just beginning to reveal. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.